Hola, and welcome to the conclusion of 5.5 in the pre-calc book. Our last formulas here are the products transformed into sums, and then we'll back up and transfer sums into products. The first a couple examples here are pretty simple. The last one might get a little tricky in some aspects. So here it says each of the product to sum formulas can be proved using the sum and difference formulas from a preceding section. And the reason they call these product to sums is on the left we have products, two things multiplied, either sine times sine or cos times cos, or sine times cos, or cos times sine. Notice the angles change. We got u's and v's. Those are different angles. So on the left we have products, and we're going to transform those products into sums or differences. So the first one, sine times sine, is a half cos of the difference minus cos of the sum. Cos times cos is 1/2 cos of the difference plus cos of the sums. So we just changed this minus into a plus. And again, that's sine sine or cos cos. Now, if we have a variety, so the first one here is sine times cos is 1/2 sine of the sum plus sine of the difference. And if we reverse it, cos times sine, that's half sine of the sum minus sine of the difference. So we identify which one is required, and we just, make angles jump in. This u and this v will jump in over here. U minus v, and then u plus v. And you'll see how simple these work out when we do a couple of examples here. And it says product to sum formulas can be used in calc to solve problems involving products of sines and cosines of two different angles. And here we go. Example 7. Rewrite the product of cos 5x times sine 4x. So let's look for the pattern cos times sine. If I go back here, cos times sine. So I'm going to copy this formula, leaving blanks where the u's and the v's are. So this is half sine of the sum minus sine of the difference. So if I go back here, this is going to be 1/2. I've got a bracket. We're going to do the sine of the sum minus the sine of the difference. So there is my template from the pattern of cos times sine, and now I put in the angles in the order they came from the original problem. So 5x goes first, 4x goes second. So this is 5x and 4x, and then again a 5x and a 4x. So now we just clean this up a little bit. 1/2 bracket sine of 5x plus 4x is 9x minus the sine of 5x minus 4x is 1x. And there's our final answer. 1/2 quantity sine 9x minus the sine of x. If you really feel like it, you could distribute the half to each of those signs, but I'm sure WebAssign would take it either way. So we rewrote a product as a sum or a difference. Occasionally, it's useful to reverse the procedure and write the sum of trig formulas as products. This could be accomplished with sum to product formulas. So now on the left are sums, and on the right are products. So on the left here, we've got sine plus sine, or sine minus sine, or cos plus cos, or cos minus cos. Notice there's no mismatches, like a sine plus a cos or a cos plus a sine. So we identify the pattern, either the sine of a sum or sine plus sine, sine minus sine, cos and cos, either added or subtracted, and then we plug in what's over here on the right side. Notice that stuff's just jumping in the formula. This u is going to jump into these spots, and this v is going to jump into these spots. So we're either going to add the angles and cut them in half, or subtract the angles and cut them in half. And if we look again here on the right side, again back on the left, this was sine plus sine, sine minus sine, and we have our coses. Over here, it's multiplied things. The sine of this angle times the cos of this, the cos of this angle times the sine of this, cos of an angle times the cos of an angle, and then sine of an angle, sine of an angle. So we identify by the pattern which one applies, and we just have our angles jump into the new formula. And here's where we're going to start this out. Find the exact value, cos 195 plus cos 105. Neither of those angles are a friendly angle on the unit circle, but as we apply the formula, it might become possible. So first, let's analyze what we got. Cos plus cos. So cos plus cos, back up here. Cos plus cos is this one. We'll call it, formula number 3, cos plus cos. So I'm going to copy this down, just leaving out the u's and the v's. So this is going to turn into 2 cos of the sum over 2 times the cos of the subtraction over 2. And then we drop in the angles. 195 goes in first, 195, 105 goes second, and then again 195 goes first, 105 goes second. Just to say again, those angles are not on the unit circle. But watch what happens. Now it's 2 cos of, if we add those, we get 300 divided by 2. And then we'll have a cos of, if we subtract those, we get 90 over 2. Okay, one more little simplifying step before the unit circle. Let's divide in the parenthesis. So this is 2 cos of, 300 cut in half is 150. That's an angle on the unit circle. And then we've got cos, 90 over 2 is 45. That is another angle on the unit circle. So, unit circle time, we're going to be multiplying. So let me write that 2 as a 2 over 1. And then we find the cos at 150. That's a negative root 3 over 2. And then the cos at 45, that's a root 2 over 2. And then we can just multiply straight across. Let's get this out of the way first. Negative times positive times positive. Our final answer will be a negative. And then we're going to have this 2 times those radicals. So that's going to be a 2 radical. Radical 3 times radical 2 is radical 6. And then in our denominator, 2 times 2 is 4. Negative 2 root 6 all over 4. And I do see the 2/4. We can reduce that fraction. So that's going to be a negative 1 root 6 over 2. Negative root 6 over 2 is our exact value. Okay, so next up, try a couple of practice problems based on examples 7 and 8. First, rewrite this product as a sum or difference. So go to the formula sheet, look for the sine times cos pattern, plug and chug. And then down here, exact value of these, you're going to find the pattern of sine plus sine, and then plug in the angles and see where the problem takes you. All right, the first one, the sine times cos pattern, sine times cos is going to be 1/2. Get back there. Sine of the sum plus the sine of the difference. All right, and then we populate in the angles. 5x goes in first, 3x goes in next, and then another 5x and another 3x. So now we get 1/2 bracket sine of 5x and 3x add up to 8x plus the sine of, when we subtract them, we get a 2x. And there's our final answer. We rewrote the product as a sum or a difference. Now here we've got the sine plus sine pattern. So if we go to our formula sheet, that's going to be 2. Get out of there. 2, and then we're going to have the sine of the sum over 2 times the cos of the subtraction over 2. And we plug in the angles, 195 and 105, 195, 105. So that becomes 2 sine of, if we add those red numbers in the numerator, you get 300, and then you cut that in half. Half of 300 is $1.50. And then we're going to have the cos of, if we subtract 195 minus 105 is 90, and cut that in half, and you get 45. And then we can go to the unit circle. 2 is 2 over 1. The sine at 150 is a half. The cos at 45 is root 2 over 2. And that's equal, if we multiply straight across, 2 times 1 times root 2 is 2 roots 2. In our denominator, 2 times 2 is 4. And then we could reduce down, I guess, that 2/4 in the front. Reduce that down to a half. Root of 2 over 2. Excellent. And now we get to a little bit of the trickier one. I think number 9, is this the last one? Yeah, this is our last one. Now we're going to use this and solve and get our answers. Solve the sine of 5x plus the sine of 3x is equal to 0. Well, we've got a sine plus a sine, and we just learned some formulas. And now remember, this is equal to 0. What we want to do is set each factor to 0, and these are not factors, these are terms. We need to turn this into multiplied terms so we can set the individual terms equal to 0. Luckily, we have sum to product formulas. So if we look on our formula sheet for the sine plus sine pattern, that's going to be 2 sine of the sum over 2 times the cos of the difference over 2. And we plug in our angles, 5x and 3x, and then another 5x and another 3x. So let's simplify this down. 2 sine of, if we add the numerators, you get 8x, and then divide by 2 is 4x. And then we'll have the cos, 5x minus 3x is 2x, over 2 is just x, equal to 0. Okay. So we've got this whole thing equal to 0, and the left side is all multiplied terms, 2 times sine times cos. So let's divide by 2. 0 divided by 2 is 0. So that just kind of makes this 2 go away. Divide by 2. Whoa. Divide by 2. It's gone. Okay, now we've got two factors multiplied equal to 0. Let's get the easy one out of the way. This is just cos x equals 0. Where does cos x equal 0? Well, that only occurs at the top of the circle, pi over 2. And at the bottom of the circle, 3 pi over 2. Now, they did not tell us to find the answers just on one trip around the circle, so we could do each of those plus 2 pi n, or combine them down to just get x equals pi over 2 plus pi n. Okay, so we got the easy one out of the way. Let me erase this. And I guess I can sort of move this over here. Maybe squeeze it down a little bit so I have some more room. Put this up here so we don't forget about it. Now, let's move on to this one. So we've got the sine of some angle is equal to 0. Let's see, where does that usually happen? Where does sine usually equal 0? Oop. So that usually happens at 0 and at pi. Oops. So sine equals 0 at 0 plus 2 pi n. And it is also equal to that at pi plus 2 pi n. But remember, this was not just the sine of x equals 0. So we would not just set x equal to those. It's the sine of 4x. 4x. And let's see here. Could we combine those? Yeah, they are straight across from each other, 0 and pi plus 2 pi n. So we should be able to get away with combining these into the first answer plus 1 pi n. So I'm going to erase that and get rid of this too. Okay, we're not quite home yet. This is 4x equals, so let's divide by 4. X equals 0 divided by 4, that's still going to be a 0, plus pi n over 4. Now, if they did say list them that are answers between 0 and 2 pi, 0 and 2 pi, what we could do is just start at 0 and just count up by fourths and get all of the answers. Oops, that was supposed to be an eraser. Get over there. So we could, Ooh, I think I keep erasing my answer. Yeah. Pi n over 4. So we'll just go through that, letting n equal different numbers and see how many answers we can get before we're off the unit circle. So when n is 0, we get 0 fourths. When n is 1, we get 1/4 pi. When n is 2, we get 2/4 pi. And then we get 3/4 pi. And we get 4/4 pi. And let me erase this. And we get 5/4 pi, and then 6/4 pi, 7/4 pi, 8/4 pi. So let's see if we reduce down the ones we can. 0 stays 0. Pi over 4 stays that. 2/4, that's 1/2 pi over 2. 3/4 pi stays 3/4 pi. 4/4, well, that's just 1 pi. 5/4 does not reduce. 6/4, well, that's 3/2. 7/4 does not reduce. And then 8/4 would take us back to 2 pi. Usually when you're on the restricted interval, you'll see bracket 0, 2 pi, parenthesis. 0 and 2 pi are the same. So 0 is touching the bracket. We'll leave the 0. But this 2 pi is sort of a redundancy. We can throw that one in the garbage. And there is a list of all our answers for the original equation on one trip around the circle. Now, they do show a graphical representation of this. If you put that in a graphing calculator, it's going to look like this. So we have where we touch and cross the x-axis are all our solutions. 0, 1/4, 1/2, 3/4, 1, 5/4, 3/2, 7/4, or no, 5/4, 7/4, and then we go back to 2 pi. Okay, what's this? The equation cos of x equals 0 yields no additional solutions. Oh yeah, that's right. You know, back on the original, we had the first one was 1/2 pi plus 2 pi n. You know, all of those other answers would have overlapped. Oops. Yeah, I forgot. You know, the first one, we got the easy one out of the way. That was x equals pi over 2 plus pi n. Well, those would just be overlaps. Here's our first one, pi over 2. We've already accounted for that. If we add pi, that would take us to 3 pi over 2. We've already accounted for that one. So that original cos x equals 0 was just, you know, sort of overlapping on good answers that we already found. Okay, I think it's time for a practice problem for you. So give this one a try. Sine minus sine, get it into a product, and then set each factor to 0. And start the video back up after you get your solution. See if your answers are right. All right, if you go to the sine minus sine formula, you'll see it is at, get back there, 2 cos of the sum over 2 times the sine of the difference over 2. And we populate in our angles 4x and then 2x and 4x and 2x. So this becomes 2 cos of, add those up, you get 6x over 2 is 3x. And then here you'll have a sine of. When you subtract, you'll get 2x over 2. The 2's cancel, so it's just sine x. Okay, just like in the example, we've got sort of an easy one here. Let me do this, bring you over here, get that out of there. So let's do the easy one first, sine x. If we set sine x equal to 0, you're going to get 0 and pi plus 2 pi n. 2 pi n. So let's combine that, 0 plus pi n. 0 plus pi n. Okay, that's the easy one. Now let's go to, we could divide the 2 out, just like we did in the example. Now let's go to this one. The cos of something is equal to 0. Well, where does cos equal 0? At pi over 2 plus 2 pi n, and at 3 pi over 2 plus 2 pi n. Can we combine these? Yes, they are straight across from each other. So let's combine them into the pi over 2 plus 1 pi n. Now remember, our angle is not x equals. This is 3x equals. So we set this equal to 3x. Okay, to get x alone, let's divide by 3 or multiply by 1/3. If I multiply the first one by 1/3, that's going to be pi over 6. Plus, if we divide this by 3 or multiply by 1/3, it's going to look like pi n over 3. Now, if you stopped there, that's absolutely fine. This is a correct answer. It would have, this problem does have infinitely many solutions. And they did tell us to just find, where I lost the problem, it got dragged. Oh, nope, there it is. Yes, solve this equal to 0. They did not restrict us to 0 to 2 pi. But let's see what our answers would look like if they did ask us how many of these are on the unit circle. Oops. So we're just going to go through letting n equal different numbers. Let me highlight here in blue. Here is n is in blue now. So if n is equal to 0, x equals pi over 6 plus 0/3, or just pi over 6. If n is equal to 1, this n is now a 1, we get pi over 6 plus pi over 3. And that is equal to 1/6 plus 2/6 is 3/6 pi, or pi over 2. If n is replaced with a 2, we get pi over 6 plus 2 pi over 3. 1/6 plus 2/3 is 5/6 pi. If n is equal to 3, you're going to have pi over 6 plus, that would be 3 pi n over 3, or just pi. And if you add pi and pi over 6, you get 7 pi over 6. So we're more than halfway around a unit circle. If we continue on and let n equal 4, that becomes 1/6 pi plus 4 pi over 3. And if you add those up, you get 9 pi over 6, and that reduces down to 3/2 pi. If we let 5 take a turn, that's going to be pi over 6 plus 5 pi over 3. And if you add those up, you get 11 pi over 6. 11 pi over 6. Now, if we let n equal 6, we're going to get pi over 6 plus 6 pi over 3, and that divides to a 2 pi. So that takes us outside the unit circle. We're already at 2 pi, and we're going to add more, and then we're going to be outside the unit circle. So if we were asked to just list the solutions, that would be the end of our list. We could only go up 0 through 5 for our solutions. Whoa. Homework. Now, the odd are not homework. Of course, the even are homework. Look for these on WebAssign. And the odd ones here we're going to do in class. So 49 will help you with 50, 52 and 53. These pair up nicely. So the homework, the even here, probably on WebAssign. Odd problems are classwork. And that is the end of 5.5, and that is the end of Chapter 5. We're almost done with trig. We got to do a couple mop-up sections at the start of Chapter 6, and we'll be done with trigonometry.